G'day, I'm Muzza. Welcome back to Modification Documentation, where I plumb pipe work for a front mount intercooler for this Caldina. This week, let's talk TIG. No, I'm not performing brain surgery. It may look like it. Here we have an array of Tig Welding consumables. I'm going to try and demystify them for you. So on this side here, I have parts and pieces generally used for stainless, mild steel welding, DC current stuff. On the right here, just a few basic parts for AC welding aluminium. So there can be a fair bit to it. Different size cups, different size insulator pieces, even different material cup. We've got a Pyrex cup there. So each cup has its place, its time to be used. So we have different size tungstens. Generally, I'm a firm believer in doing everything with a 2.4. I do switch over to a shorty, so that'll have a short style diffuser body or collet body, gas lens like inside here. They're good for getting into tight spaces. Some of the other shorty stuff, this has got a skinny 1.6 tungsten. This one has a 3.2 tungsten with correlating collet. And that collet, yes, it does go with the specific body. So that one there would be 1.6. So it would need a 1.6 collet, need a 1.6 tungsten. So collets, there's a couple of different types. This is a shorty, obviously, split type, and that's a 3.2. This one's like a taper type. So as you do up your backing cap, that tapers in. I'm not 100% sure if that is supposed to have a tapered body to go with it. I don't use them. I use the split type. Different size caps if you've got a brand new tungsten you don't want to cut up, or maybe you need to get into a tight spot. Screw that onto the back of your TIG torch. So these can be a bit confusing. Just if you're ordering them, buy them in a kit, and just use what works. So yeah, more examples of a 1.6 thickness tungsten here, 2.4 thickness tungsten with the collet. So gas lens, use it for stainless. You can get away with this type of collet body for welding mild steel, no problem. Generally I just keep my gas lens in my torch at all times and switch to those when I'm welding aluminium. So while we're talking about aluminium, tungstens. It's recommended you use zirconiated tungstens welding aluminium. I have found you can use a thoriated tungsten, no problem. TIG torches, this is where you've just got to delve into what you've got and what you need. This is a flexible head 26 torch. 26 pretty much talks about the size of the nut on the inside of it. You know, you might have a 9 or whatever, and that has like a tiny little gas hole and nut on it. A lot of people going towards a clear lens, a massive one. I don't really use them. I can see why being able to see through your cup would be able to help you on something tight. I feel that the way that this is set up, to me, it's a bit too riggedy. I mean, I'm gonna, you know, get a couple of the Furic ones and try them out. Something a little bit more stable. Obviously, we've got an array here, you know, long ones for getting into tight spaces. Big ones, you know, higher amps, higher gas, maybe not higher amps, maybe just you want more gas coverage. Quite often I'll use a different size cup because that might be my bevel. I'll walk the cup, so I'll try and get something that's like a nice radius similar to what my bevel is. I've probably missed heaps. I'm just winging it. So, this style here, this might affect people. I think this style here is mainly used with Unimig stuff. I think I've somehow used it. Yeah, like I don't rate much of the Unimig gear. I mean, the machines are probably fine. This is not like a trademark Unimig style. It's got some denotation of numbers or whatever, and I'm sticking to what is sort of industry standard. But I just thought I'd show that. It can be confusing if you go to the shop and, you know, you don't know what you've got. There you go. So that will be for a Unimig style torch. These T2 collet body, and yeah. So we'll get on with talking about the welder and how I set that up. This is my Tig Weld 205 AC/DC TIG welding machine. I've had it for about 5 or 6 years. It's been in the back of a ute that was on fire. I had to pull it out. It's got some fire damage to prove it, but it hasn't let me down. It's been a beast of a machine. Obviously being AC capable, I can weld aluminium with it. It's gone into milk factory with me, TIG welding up in pipe racks. It's been a pretty bloody good machine. I have taken it apart and had to fix up some popped off gas lines and stuff on the inside. Some people have had trouble with them. This one's been good to me. So 200 amps. Could have a little bit more range welding thick aluminium, but as far as stainless tube and TIG welding DC stuff, been perfect. 200 amps, 205 amps is great. So some of the stuff I can show you is how to set up the way that the amps ramp in. So we'll have a pre-flow. This only allows 1 second pre-flow. That's pre-flow for gas before the arc strikes. What are we on here? Okay, so pulse TIG, the hot start. So the initial current, this will be for pulse, upslope. So for pulse, that means that you'll have your base current and peak current. I can make this pulse hotter and colder at whatever frequency I like, whatever amps I like. So base current of 32 amps and then peak of 95. Pretty hot. And then you can set up your downslope, so when you push the trigger or let go of the trigger, how long your downslope will be before your arc shuts off, create a current, and then post flow. So normally 3 seconds is plenty, but you can go up to, wow, 30-second post flow. I don't know why you'd need that. So I mean, maybe I could go a little bit higher than the 3 seconds I have it set to. Very good machine. It has more than enough settings for me to play with, and I recommend Tig Weld stuff. Okay, I'm going to talk quickly about my gas setup. So I'm using argon. Obviously one flow meter to my welder. I use this Y piece. The other flow meter will go to this hose. This is a it's an air hose. So this will purge the inside of my tube. So I have it set up with quick connects. Some people might just use tape, whatever. I like to have a bit more of a solid connection, quite professional, and I'll show you what's on the other end. These are great. Quick connect. This is used in plumbing. And stick that in the end of my hose, tighten it down. That'll expand, stay in the pipe. I can easily connect to it. If you have two, you can use the other end. Obviously, when you pump a pipe up full of gas, it needs to escape somewhere, needs somewhere to push out the oxygen inside or the atmosphere inside it. So you'll have a breather hole at the other end. Quite often I'll just use a bit of tape, poke a couple of holes in it with a sharp tungsten or whatever. So this can be good. There's other ways to do it, plenty of other ways to do it. You could just stick a hose in there, tape it up, all sorts of ways. So yeah, that's purging. Y piece is cheap. Obviously here I have 2 gas bottles. I was considering potentially using one for purge, one for the TIG. You do have fluctuating readings because you're splitting it here, so you know you might have your purge going. As soon as you hit your TIG torch and this starts sucking gas, that'll drop, which is no problem really. But yeah, I had the option there. I could purge from one bottle, file the welder from the other bottle. This is inert gas. The only thing that it could do to you is potentially asphyxiate you. Not flammable, not much to worry about there. So yeah, that's the gas side of things. So previously touched on tungstens. I thought I'd just go a little bit more in depth. So a 2% thoriated tungsten is pretty common in the industry I work in, whether it's stainless or mild steel. The thoriated are the go-to industry standard. The problem with these, thorium's radioactive. So kids at home, stuff like that, it's not real good to have the dust flying around the place. So another option are these, the purple end, they're the rare earth metal. Maybe not quite as stable arc as a thoriated tungsten, but the good thing about these, apart from being non-toxic, These are recommended for AC or DC welding, so you can use them for welding your aluminium without, you know, worrying about changing to one of these, the zirconiated. So white end. There's also lanthionated. I think I've got a grey end there, whether that's lanthionated. I always get confused between the zirconiated and lanthionated. Do a lot of DC welding, so yeah, don't get into Ali all that much. I'm a pretty good welder with Ali. I've done my fair share, but yeah, it's not what I really specialise in. So I'm gonna dive a bit deeper into Ali in the future and know a little bit more about it. So yeah, there's a little bit about your tungstens. So I thought I'd just touch on how much gas you should be using. So for your welder, somewhere between 10 and 20 litres per minute. For your purge, which I don't know if I've explained properly, purge welding is when you fill up the pipe or tube with inert gas so that when you weld it, the inside of that weld won't be contaminated. So I like to crank it up, try and push as much air out of the pipe as I can, maybe 10, 12, 15, and then turn it down a bit and let it fill the tube or pipe up. What you want to make sure you do when you finish your weld and fully seal that joint, you want to just taper your purge off a bit. If you've got too much pressure, it'll blow the liquid metal out back at you and you'll never seal that up. It'll make a mess, it'll be a pain. So taper the purge down when you want to finish your weld off. Okay, I'm going to talk a little bit about welding techniques. I haven't decided yet if I'm going to break this apart and weld it in sections just to make my life easier. I'm going to weld it with what we call autogenous welding. I don't add filler wire to this. So stainless steel shrinks quite a bit. Once I weld this or fuse it, it will shrink enough that the material will become its own filler wire or filler metal. It will get flat, at least flat, on the outside and the inside. So it will be as strong as the tube. I could add a little bit of filler wire if I choose to. There's a gap, or some of these are very thin. I might just use a little bit of filler wire to keep it a bit cooler. So autogenous welding is something that's used in sanitary tube welding for wineries, milk, food grade pipe work. And I've seen some of those pipes rattling around, humming, too hot to touch. So I think for intercooler pipe, autogenous welding will suffice. So I just thought I'd show you a little technique I learnt back when I was an apprentice from some of the older pipe fitters and pipe guys. I don't see it very often anymore. Holding your pipe while you're welding it can be a real pain in the ass. Sometimes just having it in the rotator, even if you're not turning it, is a good option. This is something I've, like I said, stole from some of the old school guys. It's a chain clamp. I've made a little piece of steel with a slot in it there. And then over here, I've just taken a bolt and tacked that onto my pipe stand. So I'll show you how this works. The slot is so that I can insert the chain, and then I can just grip to this bolt here. So if you just pan back, that's very solid now. I could take this away, you know, I can put that in any position I like and weld it. I can loosen that off, turn this around. Very handy. It does scuff up your pipe. You can put a rag or a piece of carpet under there, no problem. There are a lot of options. I've got a pipe vise here. This is quite handy. I need to fix it down. It's normally on my rolling cabinet bench that's not here at the moment. This is quite handy because I can lock a pipe into there in different angles. Yeah. So there's a few different ways to do it. There's some other custom tools you can make out of a C-clamp or, you know, whatever you like. So have a play. Sometimes making the tools is just as fun as making pipe work. I just wanted to point out my rollers here. I've tacked on a thin strip of stainless steel just so I'm not contaminating any stainless pipe work or tube work that I'm doing. This roller head also has my little patented chain clamp set up on it as well. So if I want to have a pipe or tube on there, stop it rolling, use this for another pipe support, I can use this just like the other V-head stands I've got here. And yeah, this one's got the stainless strips on it. I haven't actually fit this one with my little chain clamp invention, but I haven't really needed to. If I need to, I can. So I thought I'd bring us down to earth here and talk about some options for earthing or grounding your material when you're welding it. Obviously, if you're turning something in the rotator, you're not going to clamp onto it. It's going to be heavy. It's going to twist up. So this is a solution here. Pippy long stockings. It's a bit of copper cable that I've braided together. Don't have to braid it. I just had nothing to do at work and thought I'd practice my hair braiding skills. So what you can do, if you're rotating a piece of pipe, this can go over it. You can clamp onto this and your pipe can spin freely and still have great connection, great earthing. And it's very simple just to pull that off or unclamp it. Bam. Don't have to worry about anything falling off. Don't have to worry about anything getting tangled up. Good little tip. Another little tip, if you're fabricating something small and fiddly, rather than trying to clamp onto your piece and then trying to work with it with a big clamp on there, find a bit of sheet. If you're working with stainless, use stainless. And then you can just clamp to that. That's live for welding onto it. So, you know, as long as it's sitting on there, it's earthed. Maybe seems simple, but sometimes if you don't know, you don't know. So I've got a couple of welds here, little reducer that I've flared out on my own. I've welded these using the autogenous method that I've talked about. I was just going to show you a bit about polishing them clean. You can use a couple of methods like these wheels here. 3M product. They're quite expensive, but they are good. A good brushed effect. You can get other things a little bit more readily available, like another 3M product, a Scotch Brite wheel. They're fine. Or you can even just use elbow grease and a scourer and take that back. So everything in my engine bay is going to be polished clean, brushed look. So that's how you can achieve that effect at home.